Welcome to part 2 of the Chess AI CLI tutorial. In the last video, we stopped at building this knight data class. In this video, what we're going to be working on will be building the other piece types and also writing the data class for the piece. I'm going to start working on the pawn data class. Right now, the pawn only has the member functions mentioned, but they haven't been defined yet. So we're going to start off by defining the move pattern function. How this function is going to work is we're going to determine what moves are valid for the pawn. So we need to first initialize our output, which would be called valid positions. Valid positions is going to have an output type of set position. So we're going to make it a mutable set of position. And then next, I'm going to add an helper function called add if valid. And so the add if valid will basically be adding two valid positions once, depending on certain criteria. But first, let me call the add if valid function. It's going to take in two input parameters, call offset and row offset. Now, we're going to call add if valid for when the pawn moves forwards, and then also when the move forward move, if the pawn is at the initial position of the pawn is where it was placed at the start. So if it's at row 2, then it can also move 2 spaces forward. And then there's also a case where the pawn can capture diagonally. And then we're going to return valid positions. So now let's define the add if valid function. Or actually, let's call the add if valid functions in these cases. So add if valid moving forward will only require a column offset of 1, a row offset of 1 and a column offset of 0. If the position, we're going to be checking the row of the position. If it's 2, then we know that the pawn is in its initial position. And then we're going to add if valid column offset 0 and row offset 2. Next case, pawn captures diagonally. Add if valid 1, 1. Add if valid minus 1, 1. Okay. Now we're going to define the helper function. The new column is the position column plus the offset plus 1. New row. It's the same except for the row. And then if new column in 1.8 and new row in 1.8 if clear piece positions that contains Okay, so we're checking if the destination position, so the new column and the new row, is in the current player's piece positions. So if there's a piece of that location, then we're not going to add it, but if there isn't, then we're going to add it to valid position. And then we're going to check within this if state. Okay, I think this part is good. Except we also need to check if it's not if it's a diagonal. So if it's a diagonal, we do not want to include it. Alright, yeah, this is one thing missing. Okay. Never mind that. Actually, so what we actually need to do is we need to check if it's a kill within this if statement. So we've determined that the destination location is not the current piece position, is not one of my pieces. And now we can check if it's a kill move. So it's a kill move if that location contains if that location contains the other player the other player's piece. And we're just going to add new row in the new column, and then the next condition is if it's actually not a diagonal move. So if it's not a kill, because the pawn can only kill in diagonals, and other and the other player's piece position does not contain the destination position, then we're going to add the destination position to valid positions. Let's import amps. Use Kotlin math. Okay, now that we have all of that, the helper function defined, we need to define our function isKill, which is technically another helper function. So find isKill, and it's going to have new call int new row call offset int and row offset int. Our output is going to be Boolean. And so how this is going to check if it's a kill or not is if the first of all, we need to check if the the offsets are the same. So if like the offsets are 1 1 or 1 negative 1, then so if the absolute value of the column offset and the new of the column offset and the row offsets are equal, then that means it's a diagonal move. So it has to be a diagonal move for it to be a kill move. So absolute column offset equals to absolute row offset. And so the absolute column offset has to be equal to the absolute row offset, and the other player piece position contains the new column and new row. So, and if that's true, then the output is going to be a true, so we know that it's a kill. Okay, so that's the pawn move pattern function defined. Now let's define the copy, which is also similar to the knight, except this time it's similar to the knight's function, except this time the output is going to be a pawn data class, and we're going to return pawn name point image. Okay, that looks good. Now let's go to black pawn. Let's implement. It's going to be the same implementation, except the offsets are going to be reversed. So what I'm going to do here is I'm going to copy everything I have for the pawn data class, and I'm just going to copy it into the black pawn data class. And we're just going to go line by line to check to make changes. So this is going to stay the same. Move pattern stays the same. Skill stays the same. Add if valid stays the same. Pawn moves forward is different because the row offset has to be -1. Because for the black player goes down while the pawn goes up. So this is the reverse of the white player. And then the row offset is -2, and the position.row is 7. And then the row offset for captures diagonal is -1, -1, -1, -1. The row offset is always negative. Okay, so we have that defined, and then we'll call this black pawn. The output type is a black pawn, and it will return a black pawn data class. Okay, now we have black pawn defined. Let's move on to bishop. So our bishop is going to implement the same functions that were implemented for the pawn and the black pawn, except the implementation for move pattern is going to be different. Let's define our output, valid position. So mutable set of, and the type is going to be position. This is our helper function, and then the ways that bishop can move are diagonally. So the bishop can go in diagonals, right and up, left and up, right and down, left and down. Okay, so now let's call the add valid positions function. So this is column offset 1, so it can go right, and then let's do this. It can go right and then up. We have to define the input parameters. Offset row multiplier. We're using a multiplier here because the row can increase because the bishop doesn't have to only move one space, it can move multiple spaces in multiple different rows, but it can sorry. Or actually, yeah, the row multiplier is going to be used as for multiple functions, so it's not just going to be used to increase the rows, but it's also going to be used as a multiplier for the new row. So as the column offset increases, the row also increases, and it's multiplied by the row multiplier, but you'll see that later. Okay, so this is right up, that's valid positions. The next thing we're doing is left down, so left up, sorry. Then next moves are right down. And the next moves are left down. Okay, so those are sequence of moves. And now add to valid positions. Let's define the function. We're going to have variables, new column and new row. And then we're going to use a while to iterate until the new column is reaches 8 and the new row reaches 8, and that until the position does not, the new position is not the current player's position, the current player's piece position. Don't forget to return valid positions. Okay, so valid positions, so add position, new row, new column, to column. If other player piece positions that contains So if other player piece position contains the new column, new row, then we break. But if not, so we're going to add it if it's the other player's piece position, but then once we get to that point, we're going to break the while loop so that we don't go beyond that. And then we're going to add to a new call the column offset, which is 1 or -1, and then new row becomes the row multiplier times the column offset. So we're good. So it could be 1 or -1. Okay, so this is our move pattern defined for the bishop, and now all we need to implement is the copy function, which is going to return bishop. Going to return the class bishop name points and image. Okay, we've done the bishop. Next class we need to implement is the rook. Okay, so for the rook, we need to do the same thing we've been doing for the other classes by defining the output function, which is the output variable, which is valid positions, and there's a mutable set of position. And then let's define our helper function, add if invalid, call offset, row offset. Our rook can move horizontally and vertically. So let's just define how we're going to call add if valid. So in this case, if it can move horizontally and vertically, we're going to be using offsets between -1 and 1. Okay, so this is basically just an easier way for calling all the moves that all the offsets that are valid for the rook. So basically you can move in so valid sets of offsets are -1, 0 for horizontal, and then 1, 0 for horizontal, and then for vertical 0, -1, and then 0, 1. And the output is going to be valid positions. Okay, so now in our add if valid helper function, we're going to have a variable new call because we're going to be iterating and changing the value for new call. Convert the column into a column number and add the offset. And we're adding 1 because of how our two column number is defined. And then new row, the row, and then plus row offset. And then this is how we're going to define how we're going to iterate through each row and each column in our board. So new call in 1.8 to 8, and new row in 1 to 8. Okay, so if the player piece positions contains so if it contains my own piece, like the current player's piece, then break. We're not going to add it. Or we can actually simplify this and just make it add that here. Does not contain. So this is not needed. Okay, and then we're going to do valid positions.add. New row, the new column. Okay, we have our valid position. We've added the valid positions. And then we're going to stop when the other players, once we've reached the other player's piece, that's when we know it's going to be a kill. And we're going to break. So stop if we encounter an opponent's piece. Then let's iterate on new call. So a new call is going to be column offset. We're going to add column offset. So we're basically adding 1 or -1, and new row is going to be row offset. Okay, we have all of that defined, and now the next thing we're going to do is we're going to, in copy, we're going to return rook name print image. So something else that we also need to include for the rook is the can castle flag, and this will make it easier for us later on to figure out how to determine if the king can castle or if not. Okay, we have all of that defined. What we're going to be doing next is the queen. So let's do what we've always been doing. Valid positions equals immutable set of position and then this is our helper function, and it's going to take in 2 input parameters, call offset, which is of type int, and the row offset, which is of type int2. So we're going to call these functions down here. This helper function down here, the queen can move horizontally and vertically, and the queen can also move in diagonals. So horizontally and vertically, we need to use a for loop, just like we did for the rook. The offset does not equal 0. We're going to call the helper function, offset 0, and then add if valid 0 offset. So the top is for horizontally, and the bottom is for vertically. Next, in moving in diagonals, we're going to use a for loop. Can move horizontally and vertically, and also in diagonals. So for diagonals, we're only going to consider when the column offset and the row offset are -1 and 1, or 1 and -1, or -1 -1, and or 1 and 1. So this is basically just an easier way to implement diagonals. We can replace this for what we did for the bishop, but I think it's fine for us to keep both the same, just in case you want to see all the offsets that are being used by the helper function. Okay, and then we're going to return valid positions. Now let's define the helper function. Add if valid Okay, we're defining new call, and then we're going to define new row. And then while new column is in 1 to 8, and new row is in 1 to 8, if if we encounter our own piece, then we're going to break, or let's just do this here. If we encounter our own piece, we're going to break, and then we're going to add valid positions. To column. And then we're going to check if it's the other player's piece. If we encounter the other player's piece, if we do, then we're going to break. Okay. Now we can copy this. Let's define the copy function, which is basically the same as the others, except this time our output is going to be of type queen. Okay. Yeah, so this is our data class for that was our data class for queen. In rook, we're experiencing an error. It looks like it's because can castle is not meant to be an override function, and it's meant to be a variable actually. Okay, that's better. So now we've done queen. Next we're gonna do king. Yeah, king is going to be our most complicated data class to write because it involves a lot of constraints and rules, but we can work through all of that. So let's first implement move pattern. So first of all, let's define our output. Going to be a mutable set of type position, and then can castle. Actually, we need other parameters up here to consider castle moves. So let's add a parameter called castle rook positions, which will include all the positions that the king could be in when there's a castle move. And then we're going to define our next parameter, which is var can castle. It's of type Boolean. We're going to set it as false initially as default, and then every time this function is called for this class, then can castle is always set to false initially. Next, we need to define our helper function, which is add if valid, and the input parameters are call offset of type int and row offset of type int. Okay, and then now we have that, we need to define the offsets that are valid for the king. So the king can move horizontally and vertically, and then the king can also move diagonally, or can only move 1 spaces away from its current position. So that means we don't need a while loop within the added valid function, but we're going to use the same for loop out here for horizontal and diagonal and vertical that we used for the queen and the rook. Okay, now for add if valid, let's just define our values, a new call. So we're checking if new call and new row are within 1 to 8. Okay, so this if statement, basically, so we're checking if the new position is not it's not the current player's piece and does not contain the current player's piece, and then we're also checking that the new position is not included in the other player's open moves, because the king cannot be in a position where the other player can move to. And if all those conditions are met, then we're going to add the new position to valid positions. Okay, we have all of that, but then now we also need to consider when the king is performing a castle move. So in a castle move, we need to check the in-between pieces for the king, and then we also need to add the valid positions that are a castle move to the output valid positions. So let's first define the function to check if there are pieces between the king and the rook. So fun. Okay, so what we're doing right now is so the input parameters for check in between pieces will have new king position and column offsets. So and the column offsets is going to be a list of ints, and the new king position is going to be the position. So how we're going to work through this is we're going to go through the list of castle rook positions, and then we're going to, and that will be the column offsets, or it depends on if it's a black or white. So the column offsets are going to be or actually no, it depends on whether the king, so the column offsets depends on whether the king is on the king side or the queen side. The king is on the, if the castle move is on the queen side, if the castle move is on the queen side for the white, then the in between offsets, the column offsets are going to be -1 and 1 because it can move 2 spaces. And then if it's on the king side, then the offsets are going to be -1. But you'll see how all of that implementation when I'm actually defining how we're going to add castle move into valid piece position. Okay, so let's continue. And this is just defining the new king position offset. And then if so we're checking if the new position, so the new king position offset, it contains the other player piece. converting this to a string. And then we're going to do the same for current player piece positions. It contains new king position offset. And then we're going to continue to next iteration. If this is true, else we're going to stop and return false. And this is iterating over column offsets. And then if it goes through all the conditions are met for each column offset, then we're going to return true. Okay, now let's start adding the castle moves to valid positions. So valid positions dot add all. Castle work positions dot map. So we're going to add, so within castle work position, we're going to have rows, and we're basically going to have a string, list of positions. And each position has a row and column, except we're going to be adding the place where the king can be placed. So castle rook position currently has the location of the rooks, but we want to get the place where the king can go when it's performing a castle on the king side or on the queen side. So we need to add that. So for, it's kind of complicated, but I'm going to explain all of it in a bit. We're going to be using ceiling, and I'll explain why. So basically, this is going to be the column for the castle rook position. So we're going to be taking the ceiling of the current king position, which is position, the column, the current king's column position. We're going to be converting that into an int, and then we're converting the rook position into an int. And then we're going to be adding both of that and then converting it into a double and dividing it by 2. We're dividing it by 2 because the place where the king ends up is usually on when we're casting on the queen side, the king usually ends up on for white, it usually ends up on C, and then for, is that right? Or is it B? No, let's see. Yeah, so when castling on the queen side, the king usually ends up on C, And when castling on the king side, the king usually ends up on G. And C is the third column, and G is the seventh column, and the king starts at 6 or 5. Sorry, starts at column 5, and so if it's castling on the queen side, we're going to add 5 plus 1, which is a 6, and then divide that by 2, which is 3. So that's what this is going to end up as. We're adding 1 because of the way that 2-column number is implemented. And then if it's casting on the king side, it's going to be 5 plus 8, which ends up as 13, and then 13 divided by 2 is 6.5, but we're guessing the ceiling, so it's going to end up being 7. And yeah, that's what we're trying to get. And then we're converting it into a column. And then once we've done that, the next thing we want to do is we want to filter the castle move position so that so up here we basically added we've basically made a map of all of the rook positions for the king, and then now we're filtering it out so that we can remove the castle rook positions depending on whether there are in between pieces or not. So new king position is valid. New position dot column equals to C. So we're checking if the new king position, if it's on the queen side, so we're checking in between pieces, and we're going to use new king position in list of -1 and 1. So those are the two locations where there could be pieces from C. And the reason why we're only checking those two locations is because we're assuming that the rook has not moved, and that's why we're using the can castle flag on the rook. And then we're also checking if the king has not moved too, and that's why we also have the can castle flag for the king. I feel like all of this will make a lot more sense after we've walked through and implemented a lot of what I'm talking through. Okay, return. And then we're checking if the king can castle, and if the new king position is valid, then we're going to set can castle to true, and we're going to return is valid here. And this will basically add the castle position to valid position. Okay, so we have that implemented. The next thing we need to do is define our copy function. And this will return king with all its parameters. castle rook position is going to be a new list, mutable list with a copy of its elements. Okay, so we have all of that, and then so we've implemented king. Now I think we've implemented all of our piece types. Perfect. Now let's fix piece type here and import position. And now we have all of the members that depend on piece type fully functioning. Okay, that's perfect. Now we're going to define our piece function. So let us create a new class, and it's going to be a data class, and it's going to be called piece. So this is what we're going to be defining. To have a name, it's going to have piece type, it's going to have initial position, it's going to have position, we're going to have default values, and then it's going to have open moves. And then it's going to have color. And then previous state. And we can import position and see the class we made. So color is actually going to be the color that we're going to see on the CLI to distinguish between an empty piece, a black piece, and a white piece. We can define that now over here in the utils. So what we can do is we can create an enum class for color, and the input for the enum is going to be code. We need to include a reset, a red, a green, and then a white. The codes for all of these, I'm going to copy and paste here. Okay. These are just, this is something you can find online. These are basically just codes that define how different colors are represented and how they can be used in a print statement if you want to print something in color. And then, yeah, we're not using this. We're going to be using our own util color white code. This is going to be position. Okay. Okay, now let's define the functions for our piece. So save state is one function. Previous state used to be piece. We're going to use name piece type dot copy initial position dot copy position dot copy open moves dot map it dot copy dot to sets open moves. Oh, it's because of this. Okay. Into set. And then color. And this save state essentially helps us build memory in case there's any backtracking that we want to do later on. Okay, next member function will be restore state. Name is previous state. We're going to be using previous state to restore the state to string. Piece type equals to previous state. So piece type empty. Initial position equals to previous state dot initial position. And if it's null, we're going to be using our default. This is what is called an Elvis operator. The Elvis operator basically checks if what's on the left side is null. If that's null, then what's on the right side is used instead. And then position equals to previous state. Also, this also ensures null safety, the question mark before the dot. So if previous state is null, we're going to set position as null. And we don't throw a null pointer exception. Now open moves equals to previous state dot open moves dot map it dot copy to set. Elvis operator empty set, and then color equals to previous state dot color. Elvis operator color dot white dot code. Okay, that's where we're storing the state. Next, we're going to be setting the open moves. Or actually, let's just write down all the functions that this class is going to have. So it's going to have set open moves. Mentioned here, get instance open moves, clear open moves, make empty, and update position. So set open moves as player, piece, position, list, string. It's going to be a list of strings, other, player, piece, positions, list, string, and then other, player, all, open, moves. It's going to be list of position. Okay, open moves equals to piece type dot move pattern position player piece positions other player piece positions and other player all moves. Next, get instance open moves clear piece position list string color clear piece positions list string other clear all open pieces Okay, before I move on, let me explain set open moves. So in set open moves, open moves is basically set by calling the move patterns function defined in this interface piece type interface, and it uses the input parameters mentioned here, as well as position for the current piece. Get instance open moves is different from set open moves because it does not set open moves. It actually gets the open moves for the piece type, which helps especially if you want to check like certain things, like if the open moves for this piece will affect with whether the king is in check or not. And the return type for this is going to be the set position. And then the next function is clear moves. The next one is make empty. Clear open moves, make empty, and then our last function is update position. Okay, so yeah, so this basically clears the open moves member function, member parameter. This makes the piece empty, so this can happen when the piece is captured, and then this updates the piece position. Okay, so now that we have our implementation of the piece, what we need to do next is define the interface for the player, and then also implement the game, and that will be done in our next part. Thank you for watching the second part of our tutorial. Please stay tuned for the next part.